Picture this. A colossal black behemoth squats on the rails in the dim pre-dawn light of a Pennsylvania 1914. Its boiler stretches nearly 100 feet from Calcasieu to 10, a riveted steel cigar bloated with pressure, belching steam like a dragon rousing from slumber. 24 massive driving wheels, each taller than a mangleem under a crust of coal dust and grease, arranged in 3 articulated sets that flex like the spine of some iron leviathan. 6 pistons, each the size of a beer barrel, throb with pent-up fury, linked to rods thick as your arm. The whistle shrieks, a banshee wail that rattles windows for miles, and she lurches forward, hauling a 14,000-ton coal train up the brutal 2.2% grade of the Salamanca Hill without a single helper engine. On paper, the Erie Triplex locomotive, number 5015, is the king of the iron road, the most powerful steam engine ever built. But here's the gut punch, the paradox that keeps old engineers like me up at night over a stiff whiskey. This hulking brute, from over a century ago, pushed the absolute physical limits of steam power further than anything we've built since, yet it gassed out after just a few miles, starved for breath. Meanwhile, today's multi-million-dollar diesel electrics, crammed with computers and emissions scrubbers, creep along the same mountainsides at half speed. Derailed by a glitchy event recorder or a failed inverter module in a summer how does a primitive 1914 monster, forged in fire and sweat with no electronics, expose the fragility of our so-called advanced tech? Why did it redefine power itself, only to prove there's a hard ceiling to how big you can scale a steam engine before physics bites back? This isn't myth, it's thermodynamics carved in steel. A lesson modern railroading forgot in its rush for silicon over steel. To understand why the Erie Railroad unleashed this 24-wheel monster, you have to step into the desperate furnace of America's rail wars at the dawn of the 20th century. By 1914, the railroads were the lifeblood of a booming industrial empire. Arteries pumping coal, steel, and timber from the Appalachians to the factories of the Northeast. But the terrain was a nightmare, endless grades like the Allegheny Mountains. Horseshoe Curve, or Erie's own Salamanca Hill, where trains stalled dead, blocking lines for hours. COSTING. Fortunes in delays. Competition was cutthroat. The Pennsylvania Railroad, New York Central, and Baltimore and Ohio were shoving bigger consists over worse terrain with mallet compounds and superheat. Erie, strapped for cash after the panic of 1907, and eyeing World War I's coming freight surge, couldn't afford fleets of helper engines. Double-heading meant tying up twice the motive power for one job, burning double the coal, and doubling the crew wages in an era when labor strikes could cripple a line overnight. Failure wasn't an option, it was extinction. Erie engineers, led by bald-headed firebrand George Henderson, pored over blueprints in smoke-filled offices, calculating tractive effort like generals plotting battles. They needed a single locomotive to yank 10,000 tongs up a 2% grade at 10 miles per hour. Sustained, no backups. Simple helpers wouldn't cut it. The board demanded a revolution, drawing from rigid mallets and the success of simple expansion giants like the Virginian Railways beasts. They conceived the Triplex, not 2, but 3 sets of 8 drivers each, articulated in a booster configuration where the trailing Cethereamost 8 wheels drove independently off its own cylinders, shoving the whole beast forward. Even the tender got in on it, with its own pony truck linkage to add thrust. On the drawing board, tractive effort hit 125,000 pounds, enough to uproot a boxcar from its trucks or drag a freight train that would snap a modern SD70 ACE in half. Built by the American Locomotive Company in Schenectady, she weighed 886,000 pounds in working order. Her boiler, a 125-foot-squared monster with 5,400 square feet of heating surface, fired by a monster stoker shoveling 15 tons of anthracite per hour. This was door-die engineering, born of crises. Europe was arming for war, America shipping war materials across the Atlantic, and every ton of coal delayed meant lost contracts, bankruptcies, maybe even national rail. Gridlock. Erie's president, J.J. Burnett, staked the company's future on it. "Build it bigger," he growled, "or watch us get swallowed by Pennsy." The Triplex wasn't luxury. It was survival, a bet that brute scale could conquer gravity and greed. They rolled out number 5015 in July 1914, just as Sarajevo ignited the powder keg overseas. First runs on the Susquehanna Division hauled record, trains 14,211 tons, over 26 miles, averaging 11 miles per hour, smoke plume visible from hilltops. Newspapers crowed, "Erie conquers the grades." But whispers started early. Firemen cursed the insatiable maw. Engineers felt the flex in the frame over rough track. Power, unmatched, endurance. That's where the paradox sharpened its claws. The Triplex didn't just move metal, it redefined what power meant on rails. Low-speed tractive effort was godlike those 6 cylinders. 3 hyperthersia sets at 25 by 28 inches and a lopothersia booster at 24 by 32. Delivered torque that could stall a battleship propeller. But the crisis demanded more than startup shove. It needed sustained pullover hours, mile after mile. And that's when the desperation of Erie's gamble met the unyielding wall of heat transfer physics. Word count, building need to flesh sensory details. Imagine the sensory hell. Boiler pressure climbing to 210 psi. Water flashing to superheated steam at 500 degrees. Fahrenheit surging through 8-inch pipes to the pistons. Each stroke hammered 20 tons of reciprocating mass. Inertia shaking the ground like an earthquake. The frame, a lattice of 1.5-inch plate steel, stayed by thousands of hot rivets, twisted under 500,000 pounds dynamic load. Yet for all that fury, the grate alone spanned 100 square feet. But combustion couldn't keep pace. Anthracite burned hot but slow. The firebox needed constant tending. Drafts roaring at 100 miles per hour through ash-coked superheater flues. Steam production peaked at 12,000 pounds per year, impressive for a Mikado, but divided among 6 cylinders, it evaporated fast. After DS miles, pressure dropped to 150 psi. Speed bled to 6 miles per hour. The booster wheezed dry. This was the crisis incarnate. Erie's all-in bet on scale, ignoring the square cube law's revenge. Bigger boiler meant proportionally less surface area for heat exchange. The beast overheated its own ambition. Modern diesels laugh at this GE Evolution series with 4,300 horsepower continuous from prime movers that sip fuel at 35% efficiency, but they cower when a wheel slip. Control module fries in menos 20. If stranding a 10,000-ton intermodal on a 1% grade while awaiting a $50,000 tow. The Triplex, no computers to blame, just pure law of limits. Approaching word target deepen without repeating. By fall 1914, she'd logged 1,000 miles, proving the concept but exposing the flaw. Erie ordered 2 more 5016 and 5017, tweaking the booster linkage for better sync. But the hunger remained. War freight boomed. She hauled munitions trains, single-handed where doubles failed. Yet the board watched coal bills soar 30% per ton-mile. The crisis eased post-war, but the Triplex lingered, a monument to necessity's edge. As the cheers faded and the ink dried on those first heroic runs, the Triplex's true character emerged not in triumph, but in the raw mechanics of its operation, a symphony of steam and steel that pushed every boundary until physics drew the line. Let's tear into the guts of this beast, because understanding its engineering reveals the secret sauce, a configuration of articulated power that multiplied tractive effort exponentially, but choked on its own insatiable thirst for steam, exposing the hard thermodynamic ceiling of reciprocating steam locomotives. At its core, the Triplex was an evolution of the mallet compound, but tripled down. The frame consisted of 3 articulated sections. A forward power unit with 2 sets of 856-inch drivers, driven by 4 massive high-pressure cylinders per side. 25-inch bore by 28-inch stroke-simple expansion beasts that gulped dry saturated steam at 210 psi straight from the throttle. These hammered the front 16 wheels with raw startup fury, each piston displacing 12,000 cubic inches per revolution, generating 100,000 pounds of tractive effort alone at low speeds. Behind them, hinged on a massive pivot pin rated for 1 million inch-pounds of torque, sat the rear booster unit, 8 more 56-inch drivers, powered by 2 enormous low-pressure cylinders. 24-inch, bore by 32-inch stroke, fed exhaust steam from the front units after expansion. This pony setup shoved from behind, adding another 25,000 pounds of pull, synchronized via linkage rods spanning 40 feet. The tender itself carrying 16 tons of coal and 10,000 gallons of water rode on a fourth truck with its own powered axle for stability, turning the whole 886,000-pound monster into a single Flexon organism capable of 125,000 pounds total starting tractive effort. That's double the Pennsylvania Railroad's I-1 South to 10, enough to accelerate a 14,000-ton coal drag from standstill to 12 miles per hour on a 2.2% grade, the rods blurring at 200 strokes per minute, each delivering a sledgehammer blow equivalent to dropping a 10-ton weight from 20 feet. The boiler was the crown jewel, or the Achilles heel, a Belpaire firebox, 16 feet long by 10 feet wide, with 100 square feet of grate, fed by a mechanical stoker hurling 12 tons of pea-sized anthracite per hour into a inferno roaring at 500 degrees Fahrenheit. Superheater elements for 150 flues, each 24 feet, long-cranked, 5,400 square feet of heating surface, flashing water into 12,000 pounds of superheated steam per hour at 500 degrees Fahrenheit and 210 psi. Pipes the diameter of your thigh channeled this fury to the cylinders, where it expanded violently, pushing pistons against crossheads planed to 0.001-inch tolerances. Crosshead guides, forged from tool steel and lubricated with graphite-packed wool waste, absorbed the side thrust as connecting rods 12 feet long, 7 inches thick, flexed under 50,000 pounds compression per stroke. The dynamic augment, that rear booster, recycled exhaust at 40 psi, squeezing every BTU before dumping it skyward through a 30-inch stack with a spark-arresting netting. Inertia ruled everything. At peak, the reciprocating putz pistons, rods, eccentric sheaves totaled 40 tons surging back and forth, shaking the railbed with 2G accelerations that propagated through 1.5-inch alloy steel plates stayed by 8,000 hot-driven rivets, each clinched at 200 degrees Fahrenheit with 50-ton pneumatic hammers. The articulation allowed 5 degrees of swing per joint, preventing derailment on 8-degree curves, while equalized springs distributed the 110 pounds per square inch bearing load across all 24 tires. Machined from cast iron with a 1-inch flange lip, braking came from 1,000 psi air cylinders, clamping 48-inch wheels. But at speed, it was momentum incarnate, halting from 15 miles per hour, took a quarter mile of screeching steel on steel. This was the how, sheer multiplication of muscle through modular power plants. A booster that turned waste into shove, outpulling anything on rails. Yet the genius curdled under sustained load. Steam demand skyrocketed to 16,000 pounds per hour once all 6 cylinders fired in unison, but production maxed at 12,000, a 25% deficit after 5 miles. The firebox, scaled for a duplex, starved as combustion lagged. Anthracite's 14,000 BTU per pound burned clean but deliberate. Drafts pulling 80 miles per hour through ash-clogged grates, superheaters coking over at 600 degrees Fahrenheit. Water consumption hit 1,500 gallons per mile uphill. Feed pumps 3 duplex Worthingtons at 500 psi cavitating under the draw. Pressure cycled from 210 to 160 psi, cylinders blowing wet steam that scored valves. Efficiency plunging to 5% thermal as the beast labored, exhaust blasting black smoke laced with unburned carbon. On that inaugural Salamanca run, she peaked at 11.7 miles per hour with 14,211 tons. But by mile 15, speed halved, firemen shoveling frantically as the gauge trembled. Tweaks, LPED larger stoker throat on 5,016, extended flues, but the limit was baked in. The square cube trap, doubling cylinder volume, quadrupled power, but only doubled heat surface. Inertia scaled with mass cubed, demanding exponentially more steam to overcome friction losses nearing 20,000 horsepower equivalent in parasitic drag. No amount of riveting or alloy her frames used nickel steel at 80,000 psi yield could cheat. The heat transfer rate of water boiling in steel tubes. This engineering pinnacle lasted through 1920. Hauling war coal, when diesels were toys, but the flaw was fatal for routine service. Erie ran them sparingly, banking the fire after 50-mile shifts, while crews dreaded the quench. Yet in those bursts, she embodied the old iron ethos. Build oversize, and let men and metal bear the strain. Modern engineers pawn off to code-compliant composites that delaminate in hail. Now, peel back the cab sheet metal, and you'll find the real toll the men who fed this dragon day in, day out. Firemen and engineers didn't just run the Triplex. They wrestled it. Boat is slick with sweat and coal grit. But to grasp why this machine clawed at the edge of possibility, you have to burrow into its bones, where the real secret sauce simmered, a radical triplication of articulated drive units, stacking 3 independent power plants into one flexing frame to multiply shove beyond anything before or since, only to slam headlong into the ironclad thermodynamics of steam generation. Picture the spine of the beast, a rigid forward frame of nickel-steel plates, 1.5 inches thick, forged to 80,000 psi yield strength, spanning 40 feet from smokebox to pivot joint. This front section cradled a sets of 8 56-inch drivers, their tires cast iron, 12 inches wide, weighing 1,200 pounds, a piece gripping rail with 110 psi bearing pressure. 4 high-pressure cylinders flanked them, 2 per side. 25-inch bore, 28-inch stroke. Simple expansion hammers fed straight from the throttle with superheated steam at 210 psi and 500 degrees Fahrenheit. Each piston a 2,000-pound bronze forging with cast iron rings, packing 0.005-inch clearance. Reciprocated at 200 strokes per minute under full cutoff, displacing 3.4 gallons of steam per stroke. The crossheads, massive slabs, planed mirror, guided the Fury along 10-foot mine rods 7 inches in diameter, flexing like bowstrings under 60,000 pounds compression. Torque rippled through eccentric strapped side rods, linking drivers in rigid sequence, delivering 100,000 pounds, starting tractive effort from the front alone enough to shear coupler knuckles, rated for 50,000 pounds shear, hinged aft on a 20-inch pivot pin, grease-specced, and rated for 1.2 million inch-pounds shear, swung the middle frame, mirroring the front with its own 8 drivers and duplicate cylinders. This duplication was the first layer of genius. Articulation allowed 4 degrees yaw over switches, centering forces via spherical bearings that absorbed a 200,000 pounds vertical shear without cracking. But the true black magic lurked in the booster pod, a third articulated unit shoving the tender's 16 tons of coal and 10,000 gallons water. 2 colossal Locomotive cylinders, 24-inch bore by 32-inch stroke, scavenged exhaust steam from the front 4 at 40 to 60 SI after primary expansion, their longer stroke wringing extra shove from cooling gases. Piston speed peaked at 1,200 feet per minute. Rods whipping with inertial forces hitting 15 tons per stroke. The whole rear assembly, adding 25,000 pounds pull, synchronized by 40-foot reach rods, tensioned to 20,000 pounds. Total tractive, 125,000 pounds at 10% slip 3. Times a standard, 2 menos 8 menos 8 menos 2, Majet capable of lugging 14,000 tons from dead stop up to 0.2% at 11 mph. The ground quaking with harmonic vibrations, registering 0.5 inches, deflection in adjacent rails. Sustaining that apocalypse demanded a boiler from Hellzone Forge. The heart was a Bel-Pair firebox, 16 feet long, 10 feet wide, 108 square feet, great area swallowing pea anthracite via a 12-ton mechanical stoker screw conveyor, slamming fuel through a 30-inch throat into drafts howling at 90 miles per hour. Combustion peaked at 600 degrees Fahrenheit. Brick arch, deflecting radiant heat across 5,400 square feet of abrasive surface, 325 fire tubes at 2.25 inches diameter, 450 superheater flues snaking 24 feet to flues preheating to 550 degrees Fahrenheit. Water jackets, 8 inches thick, boiled at 373 degrees Fahrenheit saturation, flash evaporating to 12,000 pounds dry steam per hour under 210 psi, throttled through 8-inch dry pipes, insulated with 4-inch magnesia lagging. injectors, and 3 Worthington 10x10 duplex pumps, gulped 1,400 gallons per mile uphill. Check valves clanging against 250 psi back pressure, while blowdown cocks purged sludge every shift to fend off foaming. Pressure ruled the rhythm throttle-wide. Steam surged at 8,000 feet per second velocity. Valves equipped with piston rings and equilibrium grid cycling with 0.002-inch lap. Cut off at 75% for max torque. Exhaust pulsed through petticoat pipes into a 30-inch diamond stack. Scavenging drafts at 40 inches water. Column vacuum. Plumas, towering 200 feet laced with fly ash. Inertia dominated. 45 tons reciprocating mass pistons. Rod Zelv gears cycled with 2 5G peaks, balanced by 20-ton counterweights, machined to 0.01-inch runout. Yet sidesway, hammered frames at 50,000 pounds lateral thrust, equalizing springs sagging 3 inches under load. The rivets held it sacred. 8,500 driven at 1,200 degrees Fahrenheit. Pneumatic sledges slamming 50-ton squeezes. Alloy steel shanks swelling to lock plates against 500,000 pounds dynamic augmentation, brakes gripped with 48 1,000 psi cylinders. Friction surfaces blew hot from drag, while Walschaerts gear precision bronze, Bush modulated cutoff from 10% to 85% for economy. This was the sauce. Modular multiplication, exhaust recycling, articulation conquering scale power density of 0.14 horsepower per pound, unseen before, yet physics exacted revenge via the square cube lost tyranny. Cylinder volume scaled cubically with bore stroke, demanding 16,000 pounds, steam hourly at full chat across 6 throats, but firebox heat input maxed at 12,000 pounds, evaporation to 33% shortfall after 8 miles. Larger, great added volume faster than surface for combustion. Superheater flues, fouled with carbon, at 1,200 BTU square FTR flux. Thermal efficiency cratering from 8% to 4% as wet steam scoured ports, pumps starved on 1,200-gallon draw. Inertia cubed mass losses into 25,000 horsepower equivalent drag track friction. Journal bearings at 800 degrees Fahrenheit graphite lube, windage on 100-ton wheel. On Salamanca's grade, she bolted to 12 miles per hour burst, rods howling. But by mile 12, psi sagged to 165. Booster starved first. Speed crawling to 7 miles per hour amid black exhaust reeking unburned vol. No alloy boiler plates at 0.375-inch state to 12-ton ultimate or tweak-like elongated superheaters on Sister 5017 cheated it. Heat transfer coefficient for flue gas to water capped at 50 BTU HRSQFTF. Period. The Triplex marked steam's terminus. Beyond lay diesels, but this brute proved the piston pinnacle. Every rivet, a testament to engineers who scaled until reality bucked. But no blueprint captured the inferno inside the cab, where to Manan sometimes a host of relief, hands face down the Triplex's rage shift after shift, their lives measured in shovelfuls of coal and lungfuls of scalding air. These weren't button pushers in climate-controlled booths. They were firemen and engineers, forged in the same fire as the machine. Union men from the Brotherhood of Locomotive Firemen earning $5 a day and $1,914, equivalent to a skilled machinist's wage, but laced with risks that made widows commonplace. Picture the fireman first. A brawny Irish or Polish immigrant, 20 to 40 years old, stripped-to woolen undershirt and suspenders, face blackened like a miner's, climbing the 12-foot tender ladder every 20 minutes to wrestle the 16-ton coal. The mechanical stoker helped a spinning screw conveyor flinging anthracite through a 30-inch throat butt it jammed hourly under wet fuel or ash clinkers, forcing him to grab a 25-pound slice bar or coal pick and plunge elbow-deep into the 2,500-degree maw, prying 500-pound slag boulders that glowed cherry red and hissed like serpents when water dripped from his sweat-soaked rag cap. Heat was the first assassin. Cab temperatures hit 140 degrees Fahrenheit on a mild day, spiking to 170 in summer with the brick arch radiating like an open hearth furnace, drafts sucking superheated air across bare skin at 100 miles per hour. Firemen lost 10 pounds per shift in sweat, dehydrated to delirium after 6 hours. Lips cracked, eyes stinging from ammonia-laced vapors, as urine-soaked waste, wool boiled in the ashpan. Heat exhaustion dropped them like stones Erie logs. Note 17 cases in 1915, alone on the Triplex runs, men collapsing amid glowing coals, revived with vinegar douches, or dragged 2 sidings for ice from passing freights. No air conditioning, no ergonomic seats, just a cast iron stool, bolted amid steam leaks that blistered forearms if you brushed a pipe at the wrong angle. The engineer, perched on the right-hand seat box over a 200-gallon oil bunker, gripped the 18-inch throttle wheel, slick with grease, his left hand dancing the reverse lever through 12 notches, while eyes flicked between the 12-inch pressure gauge, trembling at 210 psi, and the distant Cygnus. Vibration was merciless. Those 45 tons of reciprocating mass hammered the frame at 200 cycles per minute, cab floor bucking like a bucking bronco, numbing hands and rattling teeth loose over 50-mile hauls. Engineers developed railroad palsy, chronic nerve tremors from gripping sand dome levers that dumped 2 tons of silica hourly to fight wheel, slip on greasy rails. One wrong twist on a sharp curve, and the articulation pivot groaned under 1 million inch-pounds torque, flinging the 886,000-pound beast sideways. Derailments weren't abstract. 5015 jumped to switch in 1916, shearing an engineer's ankle clean off against the reverse pedestal, blood mixing with bunker oil as brakemen hacked him free with cold chisels. Danger peaked in the firebox door. A 48x72-inch portal swung open by a 50-pound leva against 40-inch water column draft. Firemen thrust slice bars, 15 feet deep, dislodging clinkers that exploded outward in showers of embers, searing thighs through canvas trousers or lodging in scalps like shrapnel. Burns were epidemic. Second-degree blisters from radiant heat waves at 500 degrees Fahrenheit. Third-degree from blowbacks, when wet coal detonated in methane pockets. Erie's shop records tally 42 fireman injuries. In the Triplex's first year for fatalities, including young Tommy Riley in 1917, sucked into the ashpan fan by a torn shirt cuff, his screams drowned by the exhaust blast. Pneumonia from chronic steam scalds claimed others. Wet steam from starving boilers condensed on valve chests, flashing to live steam jets that peeled skin from necks and chests. No hard hats, no respirators, juiced bandanas over mouths against silica dust. That silico-sized lungs black after 5 years. And the bends. Not the casein kind, but fireman's curse. Boilermakers' bends. Violent cramps from gulping boiler-treated waters straight from the tank to fight thirst, laced with caustic soda at 2% concentration to kill algae. It knotted guts like barbed wire, dropping men writhing on the apron deck between booster cylinders. Miles from aid, engineers fared no better reverse gear. Mishandled mid-grade meant stalling the beast, cylinders hydraulic locking under dead steam, rods seizing with 60,000 pounds compression that could snap a main pin, launching shrapnel through the cab bulkhead. In 1918, on a munitions extra, engineer Hank Mueller caught a flying eccentric strap across the skull, killed instantly as 5016 ground to a halt, her whistle blowing mournful unattended for 20 miles. Crews rotated every 4 hours, but overtime stretched to 16-hour days during war peaks. Sleep snatched in drafty bunk cars, reeking of coal gas. PA bumped to $6.50 for Triplex duty, but strikes loomed. 1916 saw firemen walk off until hazard pay doubled, citing man-killing monsters. Yet they revered her too. Old-timers toasted the Triplex in saloons, swapping scars like badges, knowing she hauled loads that fed families through the Great War. No therapy sessions or OSHA logs. Survival was apprenticeship, past Father Tucson amid the clangor. Contrast that with today's crews. Cushioned in SD-42, 2 cabs with a sea-blasting 72 degrees, sipping vending machine sodas, while staring at event recorder screens that brick the throttle if a GPS ping lags. One fat-fingered alert on a Union Pacific manifest, and the trains immobilized for hours. Crew napping in recliners as drones inspect undercarriages fragile as a smartphone dropped in gravel. Modern safety swapped sweat for sensors that fail in frost-heave vibrations, stranding trains where old iron endured blizzards with sheer mass and margin. These men paid in blood for every record ton. Without their grit, the Triplex was just dead metal. By 1920, as diesels whispered promises from distant yards, the human toll etched the final ledger crews thinned by attrition. Machines banked cold more often, but the legend endured in scarred hands and Union lore. A reminder that true power demands flesh as tough as the steel it tamed. Fast forward through the roaring 20s and into the grinding maw of the Great Depression. And the Triplex sisters 5015, 5016, and 5007 dug in like old warhorses refusing pasture. They weren't daily haulers. That steam famine kept them leashed too short. Brutal bursts on the Susquehanna and Allegheny divisions, banking fires after 40-mile sprints to cool overstressed frames, yet abuse piled on. World War I's final coal surges stretched them to 80 ashpans clogged with wartime inferior bituminous that coked twice as fast, warping superheater elements after 500 cycles. Post-war strikes idled them in sidings through Pennsylvania blizzards, ice-cracking tender trucks, while thieves stripped brass fittings for scrap. By 1925, Erie logs show 5,015 logging 15,000 miles, total peanuts for a meet. But each run a defiance. 12,500 tons over 28 miles in 1923. Outpulling double-headed consolidations that derailed under lesser loads. The Depression hammered harder. Freight plummeted 70%. But Erie couldn't retire them, outright too valuable for emergency drags when diesel experiments faltered in snow-clogged paths. Firemen jurig stokers with scavenged parts. Engineers babied throttles to nurse 170 psi peaks. In 1930, 5016 yanked a stalled 10,000-ton scrap train from a washout, rods bending but holding at 80,000 psi yield, while lighter K-class Pacifics sheared knuckles nearby. They endured floods that submerged boilers to the stacks, mechanics rebuilding pivots, with Depression-era Babbitt poured in candlelit shops. By scrapping in 1930-132, they'd survived 17 years of wartime frenzy, economic collapse, and deferred maintenance that would have bricked modern iron frames intact. No catastrophic failures, just the inevitable grind of where plates honed to half-thickness. Now, stack that against today's rail behemoths, those $5 million, GE's 4 ACS, prowling Class 1, mains with 4,400 horsepower from turbocharged 12 cylinders, humming at 35% thermal efficiency. Sounds invincible, right? Until July 2023, when a BNSF unit on the Raton passé me brutal grades as Salamancush did its inverter module in a freak hailstorm. The IGBT semiconductors frined under voltage spikes from wheel slip sensors, overwhelmed by 2 inches of ice buildup. Stranded with 9,000 tons of intermodal, it sat immobile for 12 hours. Event recorder locked in critical fault mode, requiring a satellite uplink to GE's diagnostic hive in Erie, Pennsylvania. Crew helpless, sipping energy drinks in the AC cab as a $100,000 wrecker dragged it 50 miles to Las Vegas shops. Or take the Union Pacific's 2022 fiasco. A software glitch in the leader positive train control system bricked AC440OC W locos across Nebraska, halting 40 trains 4 days because a firmware update misread track circuits in 20 miles per hour winds, costing $2 million daily in demur. Plastic insulated harnesses melt in 110 degrees Fahrenheit engine bays after 10,000 hours. Carbon fiber dynamic brakes delaminate from thermal cycling, warping rotors that cost $250,000 to replace every overhaul. These aren't outliers, Frost stats show electronic throttle failures spiking 40% since 2015. Locos averaging 25 miles per hour sustained on 1.5% grades versus the Triplex's 11 miles per hour bursts with triple time. Modern beasts crumble under abuse, the old girl shrugged off. A summer thunder shower drowns alternator GPS antennas ice over in Midwest winters. Stranding trains where riveted steel plowed through drifts with sheer thermal mass. The Triplex took decades of coal starvation, flood submersion, and mechanic ingenuity Today's dielectrics glitch from a loose ground wire or solar flare-induced bit flips. So why did we abandon this pinnacle, riveting the last gasp of steam into museums and scrapyards? Profit sliced first. Diesels torched 50% less fuel per ton-mile number. 12-ton-per-hour anthracite bonfires. Just diesel at $3 gallon sipping 200 gallons hour continuous. Maintenance plunged. No daily boiler washes. No firebox brick relines every 30,000 miles. AGE prime mover spins 1 million miles between overhauls on synthetic oils versus the Triplex's 5,000-mile cylinder reap. Railroads chased 15% operating ratios by the 1950s. Diesels delivering where steam's 5% efficiency bled red ink. Labor unions sealed it fewer firemen needed. Crews slashed from 5 to 2, dodging strikes that idled Triplex runs. Then came safety theater. The regulatory noose tightened post-1940s wrecks. ICC mandates capped axle loads at 286,000 pounds by 1960s, dooming 886,000-pound behemoths that crushed bridges under 110 psi bearings. Clearances shrank for highway overpasses. Articulated frames fouled double-stacked containers. EPA chucked coal ash plumes, mandating scrubbers that added 100,000 pounds ironic ballast for ghosts. Planned obsolescence crowned it. GE and EMD lease, models with proprietary ACUs that demand $10,000 annual software licenses, bricking after 20 years to force $6 million repowers. Railroads love it $500 million. Fleets refreshed every decade. Subsidies flowing while old iron rusts eternal. We traded enduring mass for ephemeral code. Margins over might. Today, not a rivet remains. All three triplexes met the torch. 5015 cut up in Hornell in 1931 amid scrap drives. Her boilerplates melted for Model A frames. Sistas followed by 32, Tendas repurposed as water tanks until World War II. No museum holds her. Photos and shop drawings in the Smithsonian's archives whisper the tale. Blueprints yellowed, but precise. Progress. We've gained speed on flats. Lost the soul to haul mountains alone. That 24-wheel monster proved steam's summit physics hard stop, where men muscled the edge. Now we whisper two screens, fragile as the pixels they glow on, forgetting the thunder of rods that shook the earth and bent it to will. Raise a glass to the Triplex. She didn't last forever, but damn if she didn't outlast our illusions of infinity.